So this is the impact of teacher value-added earnings by age, which, like I said, follows this unusual pattern. Well, now that you've seen the impact on college attendance, maybe it doesn't seem unusual. Impacts on earnings at age 20 are negative, right? We have negative impacts on earnings at age 20 because I'm putting a lot of people in school. They're not actually in the labor market. They only turn significant and positive once we hit 26, 27, 28 years old. And what else you can see is that they're growing over time. The impacts are growing over time. Now, one thing we can do is we split the data up. We said, let's look at the school you attend. And let's ask, based on prior students, do kids in this school tend to go to college or not? And we split the data in half. The schools where below the median fraction of kids were going to college and above the median were going to college. And we can look at impacts on earnings across these two halves of the sample. So here in red are the impact of your teacher on earnings for kids attending elementary and middle schools where very few kids end up going to college, okay, or in previous cohorts ended up going to college. And what we can see is for these kids, impacts on earnings are positive from the very beginning, right? And they grow over time. For the kids attending schools where kids do go to college, where there's more likelihood of actually them attending college or not, that's where we see the negative impact being driven from. And then the impacts on earnings shoot up. You know, there's a very strong growth trajectory because these kids are the ones that are having their earnings depressed in the early and mid-20s when they go to school. Okay? But both of these things by the late 20s are positive, significant, and you can see the trajectory is positive too. So even if, you know, when you take this number at age 28, that's the last year we look at because past that year we don't have a big enough sample to get a statistically significant result. We get actually bigger point estimates. So if we look at age 30, that graph would still keep going up, but the standard error gets much bigger. But you might imagine that what you're really getting is an increase in a shift in the entire earnings trajectory, right? Not just a flattening out at the point estimate we get at age 28. Okay, this just shows, I think, the same results in table form. Like I said, the impacts on college going are all being driven by the students attending schools where kids tend to go to college. And this just shows you we get impacts on wage growth, but you already saw that from the graph. So this is some of the two alternative outcomes I mentioned before. This is our measure of teenage birth. We don't really have birth records. We have, are you claiming as a dependent on your tax return a child who was born when you were a teenager? But we see pretty clear negative impacts. This is obviously only for females. Okay? And this is our measure of neighborhood quality, which is the fraction of people in your neighborhood, your postal code, who are college graduates. So you're living in the students who had higher teacher value added are living in nicer neighborhoods. Okay. So you know what? I'm going to skip through this. This is the issue where your fourth grade teacher might be better and you earn more money, but why was that? Well, the one thing we can net out is if your fourth grade teacher was better, did you get a better fifth grade teacher, a better sixth grade teacher, a better seventh grade teacher, a better eighth grade teacher? Because we know who those teachers are, and we can subtract out those later impacts. If there was this strong dynamic tracking, we can net that out. We do, it doesn't really make much of a difference, so I'm going to skip that. Okay? And let me skip to the sort of the two policy proposals which give us some bigger headline kind of numbers here. So Rick Hanashek, who I know you have seen talking about the value of teachers, he said what would, you know, he asked this in a 2009 paper, what would be the gains from replacing teachers who had value added in the bottom 5% with teachers of median quality? So let me just, I'll come back to this. What would happen, imagine, let's look at this blue curve. What would happen if we could take these teachers in this highlighted area, the bottom 5% of value added, and replace them with a teacher at the median. Okay? He doesn't say how you're going to do it. Right? Easier said than done. But let's just imagine we could do it. Wave your magic wand, cast your spell, and poof, those teachers become average quality. Okay? And then we can talk about policies that might be able to do it, but let's just imagine we could do that. What would that be worth? So what we do is to get this number, we're going to use our estimates. Okay? We're going to make a bunch of assumptions that we have to make. Right? The first is we're going to ignore any general equilibrium effects, like, well, I got the better teachers, so I went to a better high school, and you got a worse high school. Okay? We're going to ignore any of the non-monetary gains. So there's a lot of people that are pushing the fact that, look, getting a good education is not just about labor market returns. There's lots of other benefits of being well educated, and you can get all that from surveys. That may be true, but we're putting that aside because we don't really have a direct estimate of how much having a good teacher affects your happiness. Okay? But there's a lot of evidence that getting a good education makes you happy in other ways besides money. We're going to assume a constant percentage impact on earnings over life and use our data on tax returns from people at all parts of the life cycle. We're going to assume a 2 percentage point wage growth and a 5% discount rate. And then, you know, if you don't want it, this gets cut off, but if you don't use the discount rate, you can just multiply our numbers by 5. If you want the undiscounted sum of total future earnings, just multiply the numbers by 5. Okay? We also have to deal with which is another important limitation, which is Hanushek assumes you can just figure out who these people are and replace them with a median person. But we actually don't know who these people are with certainty. We have an estimate of who we think the worst 5% of the teachers are. And that estimate, that's that red curve here, is imperfect. So what we're going to show you is what would happen if you could do Hanushek's magic policy. You know who these people are certainly, but I'll also show you what we think we would get if you used real data where you were getting people who were low performing, but some of the people who you say are really bad are not so bad. Okay? That's important. So this is the headline number for the paper. This is the discounted version. So if you want to use the undiscounted number, you multiply that by 5. If you could do Hanushek's policy, you would get in present value for that classroom of kids in lifetime earnings, you'd get over $250,000 for replacing the bottom 5 percentile teacher with an average teacher. And it's symmetric, so if you want to take an average teacher and turn them into a top 5% teacher, it's the same thing, over $250,000. And the way to say that is the difference between the bottom 5% and the top 5% is over $500,000 in future earnings for these kids. Okay? It's a huge number. Now, you might say, okay, but you don't know who the bottom 5% are. You're going to let go of some people or do some intervention that makes them average, whatever it is, but you're going to do that on a group you don't know perfectly is the bottom. What would happen if you used our data and you used the amount of reliability we know is in the data? Well, if you just used 1 year of data, we find that you would get something like $130,000 in present value. You'd get about half of the impact that you would have gotten if you knew things with certainty. If you use 3 years of data, you're getting almost $200,000 of value, and then the additional improvement with future years of data is not so much. Okay? I mean, it's going to approach that red line when you get out to infinity. Okay? But you're still getting a lot of value if you could implement such a policy, even though you know teacher performance with uncertainty. Okay? Even with only a few years of data. Okay? We compare this, when people often think about this policy, right, they think about a policy of basically firing people. Okay? And that's fine. I'm perfectly willing to think about that policy, right? So take the people who scored the worst, right, the lowest 5% of teachers after 3 years, fire them, and then hire new people. And let's hope that those new people are of average quality. And most of the evidence suggests that they probably would be of average quality, because the evidence is we don't really know how to hire teachers very well. Okay? But let's say this is the number you'd predict. Let's compare that with another policy, which is, what about retaining high-performing teachers? Right? Instead of firing the bad ones, let's just try to retain the good ones. What would that do? Well, the key thing we illustrate with this exercise is that this policy is not as cost-effective. Okay? And the reason is that when you fire somebody, right, or you take away their license to teach, you can guarantee they will no longer teach in the classroom. So for every teacher you fire, that is one teacher out that gets replaced with an average teacher. Okay? But when you pay, let's say, a bonus or give a raise to a high value-added teacher with the purpose of retaining them, often you are paying that bonus or giving the raise to somebody who was going to stay anyway. Right? You only make a difference in those cases where that person was going to retire or going to leave for another occupation, okay? And now they decide to stay because you paid them a bonus or more money or gave them a job title or whatever it is you're doing, okay? And so even though the benefit of keeping a very high value-added teacher who was going to leave is very large, most of the time you're paying bonuses to people who are going to stay anyway. So on the cost effectiveness, it's not as good, right? So the retaining a teacher whose value added is in the top 5% based on 3 years of data gives you that gain I just said before of almost $200,000. However, okay, let's think about how much this costs per payment. So Klottfelter et al., they have a paper from North Carolina. This is just one estimate, but it's probably one of the more optimistic estimates in the literature. They say paying a $2,000 bonus to high-performing teachers raises teacher retention by 1.5 percentage points. Okay? 1.5 percentage points. This gives us an earnings gain of only a little over $3,000. Now, that's still a good investment because you put in $2,000 and you got $3,000, a little over $3,000 in return. But why is it not a great investment the way that, you know, getting rid of the bad teacher is? It's because almost all the time, right? So you'd have to pay bonuses to 60 teachers to help retain one teacher on average, right? When you pay bonuses to 60 teachers, 59 of those teachers weren't leaving anyway. And so you paid 59 of those 60 bonuses, how do we say in Spanish? Al pedo. That's how the Argentines say it, at least. Okay?